Today we're going to be starting chapter 8, and this is all about samples and populations. I would like you to write down these things for the important information, please. All right, the first thing I want to talk to you about is population. It says here a population is an entire group of people or objects. So let's talk about the population of Jacksonville. Does anyone have a guess of how many people you think live here in Jacksonville? What do you think? 3 million, not quite that big.
300,000.
More than 300,000.
500,000.
More than 500,000. About 1 million. Jacoby, very good. If you would, come on up to grab a piece of candy. We've got about 1 million in our population here of Jacksonville. Now let's talk about the next word. Everyone say sample. A sample is a part of a population, okay? There's two kinds of samples. Repeat after me. Unbiased?
Unbiased.
Unbiased would be a good sample. So if you guys want to, right here next to that, I want you to write good. Give yourself maybe a little smiley face, okay? Now there's only a certain way that something can be unbiased. It has to be large and random. Everyone say large and random. If it's not large and random, then it's not going to be accurate, which means it would not be a good sample. Let's talk about the next one. Biased. Everyone say biased. Everyone say biased. All right, next to it, I want you to put bad and a sad face. You do not want a biased sample because it is, as it says here, not representative of a population, because one or more parts of the population are favored. Let's talk about biased. If I come to you guys and I say, guys, I have to tell you, my kids are the absolute cutest kids in all the world.
That's biased.
Would you say that's biased or unbiased?
Biased.
Reagan, why is that biased?
Because you're bragging about your own kids.
Okay, because it's my kids, so I have a biased opinion. I favor them because they are mine, okay? We want to avoid biased samples. Instead, we want them to be, repeat after me, large and random.
Large.
All right, so let's talk a little bit more about the difference between population and sample. I have up here a picture of Lucky Charms and some marshmallows. Raise your hand if you are a Lucky Charms fan. I remember as a kid, I used to pick around. I would eat all the brown pieces first, and I would save what at the end?
Yes, the marshmallows.
Why would I save the marshmallows at the end?
They save it for last.
Because it's the best and we save it for last, okay? So let's just talk about the difference between population and sample. Which one do you think is the population? The box of Lucky Charms or the marshmallows?
Marshmallows.
The population is the big thing.
Lucky Charms.
The sample is the little part from it. So in this case, the population, the big part, would be the box of Lucky Charms. Now the sample is the small part of a population. In this case, this was obviously the most popular, was the marshmallows. All right, the next one, once again, we're trying to identify what the population would be and what the sample would be. Guys, which one would be the population? The residents of Jacksonville or the residents of Florida?
Residents of Florida.
Okay, the residents of Florida is the larger amount, so that is going to be our population. And what would the sample be? The residents of Jacksonville, because that's just a part of the larger population. You guys see what the difference is between population and sample? Okay. Okay, so for the next one, we are going to determine if the sample is biased or unbiased. Remind me again, guys, which one is the good one and which one is the bad one? What's good?
Biased is bad.
Biased is bad. Okay, and unbiased is good. So let's look at our notes up at the top. In order for something to be unbiased, I said there were two things it has to be for accuracy. What are those two things, guys? Everyone say it one more time. Large and random.
Large and random.
All right, so let's look at problem A. Jonathan, read me what problem A says.
We want to estimate the number of 12th grade students in a high school who eat pizza for lunch. You said they always eat from the soccer team.
Okay, so I want to know who's eating pizza for lunch
Me, actually.
out of 12th grade. So I go to the soccer team. Do you guys think that's a large and random sample?
No, not at all.
No.
The soccer team.
I am only focusing on the soccer team, as she said. That is not random. What happens if the soccer team is all on a diet and they're boycotting pizza? Is that really going to give me a good representation of all of the 12th grade students? No. So guys, would you say this is biased or unbiased?
Biased.
This is definitely biased, and I want you to write this explanation down. The sample favors, okay, or it's in favor of only the soccer team and not all of the 12th graders. All right, so let's look at another example here. Remember, as we are looking at this, we want to look at who is being surveyed, okay? You want to estimate the number of students in a high school who ride a bus to school. So you survey 100 students at random during lunch. Would you guys say that's biased or unbiased?
Unbiased.
It is unbiased. Can someone explain to me why this would be considered an unbiased sample? Luke, what do you think?
Because like, well, the other one that we just did with the soccer team was like they're singling in on one group.
Okay.
Because this, it's not going to be just like one group of people, it's going to be like a whole bunch of people.
You're right. We were not looking at just one group of people. Instead, this was a large and random group of people. So because the sample is large and random, this would be considered an unbiased sample. Let's look at problem C. You want to estimate the number of 8th grade students in your school who find it relaxing to listen to music. How many of you would say you enjoy listening to music? Okay, so quite a few of you. So for them, they're trying to guess how many people in 8th grade also feel that same way. So you decide to survey 15 randomly selected members of the band. We love to see that word random, all right? Now let's focus in on this idea. Raise your hand if you think it's a biased sample. Raise your hand if you think it's unbiased. All right, so we've got people who believe both. And I think right here, this word, when we see random, it's like, oh yeah, of course, it's random. But who can tell me why this is not the best sample to figure out about the 8th grade students who think it's relaxing? Autumn, what's wrong with this?
So because it says on the band team, and it shouldn't be just for band members, it should be in like the whole 8th grade school.
You are correct. This is definitely a biased sample because I didn't want to know just how the band felt. Honestly, the band probably really likes listening to music, but what about people not in the band? I want to know about all of 8th grade. So that is correct. This would be a biased sample because the sample, first off, is small. There were only 15 kids there, and it 100% favors the band. I only got the band's opinion. I did not get everyone else's opinion who says maybe they're on the soccer team or maybe they're on the football team or maybe they're not involved in extracurricular activities. We wanted to know about everyone in 8th grade, not just the band. So this was biased. All right, after you turn the page, I want you to write this down right here in your red pen of your notes. There's two things that you'll see here. Everyone say unbiased.
Unbiased.
An unbiased sample basically is saying the conclusion is valid or it is truthful, okay? Then you come over here and you see biased. We learned biased is bad. That's not a good sample because the conclusion in this case is not going to be valid. So let me give you a couple examples of what this is talking about. Number 3. You want to know how the residents of your town feel about adding a new landfill. Determine whether or not the conclusions are valid and then justify your answer. How many of you would say you have a job at home and your job at home is to take out the trash? Okay. Jace, when you take out the trash, where do you have to take your trash to? The bin. Where is the bin at? In your garage, okay? How many of you would say you keep your trash can in your garage? How many of you have it outside, maybe in the backyard or on the side of the house? Okay, when you put the trash bag in there, how does it typically smell?
Oh, nasty.
It smells nasty, okay? Then, once a week, the trash people come, and what do with our trash? They take it away. Guess where they take it?
To the landfill.
To the landfill. Guys, how do you think the landfill probably smells?
Horrible.
Okay, how many of you would love to have a landfill right behind your house? Maybe like your backyard. No, why would we not want that?
Because it stinks.
Because it stinks, okay? So that brings me to today's question. We are trying to figure out whether or not this is valid or not, and then we're going to explain why. So here's what it says. You survey 100 residents. Is that a good number? Is that a large number?
Yeah.
Yes, that's a great number, okay? So that's large. You survey 100 residents who live closest to that new landfill. Table A shows the results. How many people supported it, guys? 10. How many people didn't support it? 90, okay? So from that, we figured out 10%, 10 out of 100 people support, okay, of the residents of your whole town, support the new landfill. Would you guys say that's a true statement or that is not a true statement? Okay, here's where you guys messed up.
It says it's the whole town.
The residents of your whole town. Guys, did I go out and ask the whole town?
You only allowed
Who did I ask?
100 people who live.
I only asked those who live closest to the landfill. Do you think the people who live closest to the landfill feel the same way as people who live way far away from it? No. So guys, is this valid or not valid?
Not valid.
It is not valid. Can someone explain to me, why is this not a valid conclusion? Why not?
Because you surveyed the 100 people closest to the landfill.
You are
and not
correct.
the whole town.
Very good, okay? So I want us to focus on this. What we have to understand is the conclusion is biased. Remember, biased is bad. If we want something to be unbiased, it has to be large and random. The conclusion here was biased because, as she just told us, it only asked or it only focused on the people who lived right there closest to that new landfill. Therefore, no good. It was biased. It was not good, which means it was not valid. That was not a true conclusion because it did not ask the entire town. All right, let's look at one more kind of like this. We're trying to figure out once again whether it's valid or not valid, okay? You survey 100 residents at random, okay? We like to see when it's random. Table B shows the results. You conclude that 60% of the residents of your town do not support the new landfill. Let's talk about this number, 60% right here. Don't support, 60. 60 out of 100. Is 60 out of 100 60%? Yes, it is, okay? So now we've got to figure out, guys, is this a valid conclusion or not a valid conclusion? Who can help me with it?
It's fine.
Jocelyn says she believes it is valid. Can you explain to me why you think this is a valid conclusion?
Let me think.
Remember, valid means it's unbiased. How do we get an unbiased conclusion?
They chose a big amount.
Because they chose a big amount. It was large and
What was the other word?
Random.
Random. Yeah.
and random. You are very good. So write this down. The conclusion is unbiased. Remember, unbiased is good. That's what we're looking for. And in order for something to be unbiased, the sample has to be large and chosen at random. Excellent description, Jocelyn. Thank you very much. All right, so there's a new formula that we're going to be using here today. If you would, write it down with your red pen, and then I just want you to put a little cloud around it so that you can see this is our new formula. Have we ever heard of something like this, favorable over total? Yes, we used that back when we were doing probability, okay? So our new formula for today is favorable divided by the total surveyed equals n over the population. Let's read this. You ask 75 randomly chosen students at a school how many movies they watch each week. Let's look at the conclusions we came up with here. How many of them watched one movie according to that little pie graph? 21. How many watched 0 movies? 30. And how many watched 2 or more movies? 24. Now, I am trying to figure out how many movies they watched. There are 1,200 students in the school. Estimate the number of students in the school who, I want you guys to underline this, watch one movie each week. All right, so let's talk about this word estimate. Guys, what does estimate mean?
Guess.
Yes.
It's an educated guess, okay? So we're taking a good guess here. Why do you think, if I want to know how many people watch one movie, why do I not just go ask all 1,200 students?
Because that's really hard to go ask a bunch of people.
That's a long time it would take me to ask 1,200 people the same question. So here's what we do instead. We take a sample of the population and take our best guess or estimate what we think the answer might be. So let's start with our formula here. Favorable over total. Guys, what am I looking for right now? How many people watch what?
Movies.
How many movies?
1 per week.
1 per week. According to my graph here, how many people watched only 1 movie per week?
21.
21. Out of how many total did we survey?
75.
Out of 75. Part over whole, or favorable over total. 21 out of 75 decided, hey, I only watch a movie per week. Equals N over the population. N is what we're looking for. How many total people we are guessing watch a movie a week. Divided by, Michaela, how many total people are there in the school?
1,200.
Divided by 1,200. Jocelyn, what do I need to do now to discover what N might be?
Divide?
Cross multiply.
We're going to cross multiply. Okay? So on the left side, we're going to put 75 times N equals, Reagan, what will I put on the right side?
You multiply 1,200 by 21.
Very good. All right, someone help me with what that answer would be. Jonathan, what'd you get?
25,000.
Very good, 25,200. Madison, how do I get N by itself? You divide 75 on both sides. Jacoby, what's the answer? 336. Jocelyn, what are the units that I need attached? Because anytime it's modeling real life, I want to know 336 what?
336.
Not movies. Go back, estimate the number of students, okay? So we're going to say 336 students. Now, did I go out and ask all those people that, or did I just take a guess? I made an educated guess. I estimated by taking a part of it, and I surveyed only a part, okay? And that helped me to guess. Probably about 336 of those 1,200 students are watching one movie each week. Are there any questions about this one? All right, let's move on to another problem. You ask 50 artists about their favorite art form. Determine whether or not your conclusion is valid and justify your answer. You conclude that 15% of the people chose painting. I want you guys to circle 15% with your red pen, and I want you to underline chose painting. Right now, I'm trying to figure out if those two are valid or if those two are truthful. Okay? So in order to do this, let's start with favorable divided by total surveyed. Nasir, how many people did we decide chose painting according to this little graph that we have over here? 6 people chose painting as their favorite. Abigail, how many total people did we ask about their favorite art form? We asked 50. 6 out of 50. Now, if our whole goal is to turn this out of 100, we could do some mental math. Guys, 50 times what number equals 100? 2. 6 times 2 is 12. Okay, so that tells us it's 12%. If you don't know how to do that mental math, you could simply just put 6 divided by 50 into your calculator. You will get 0.12, which equals 12%. Guys, let's go back to what it says. You conclude that 15% chose painting. Was that truthful according to what we just came up with?
Nope.
No. So guys, is this valid or not valid?
Not valid.
It is not valid because it was not a true statement. Instead, our reasoning, it says justify your answer is, it was only 12%. It was not 15%. Therefore, it was not valid or it was not truthful. Okay, so last test, we had some review problems on there, and it felt like many people completely forgot how to do those problems I had taught you before. So I'm going to slip in some different review problems to see if we can understand, and your first homework problem is going to look a lot like this. So we're solving the inequality and graphing the solution. Guys, who is X's best friend here?
5.
The 5. So keep that together as long as possible. Jocelyn, what should I get rid of first?
4, so you subtract 4 from each side.
Very good. Once I do that, Jocelyn, what should it say?
Then it should be 5x is greater than or equal to 10.
Very good. Ellie, how do I get X by itself?
You divide by 5.
Very good. When I do that, Jonathan, what do I get? X is, Jace, can you help him? Okay, not just 2. What else do I need to bring down? Very good. Greater than or equal to 2. How many of you would say you did get that on your own? Okay, I want you to box that in. Now let's talk about how to graph it. Jacoby, how many numbers are on my graph?
3.
3 of them. Luke, what number goes in the middle?
2.
2. Luke, what's to the left and the right?
Oh, 1 and 3.
1 and 3. Very good. Abigail, open or closed circle?
Close.
Closed. Why is that a closed circle?
Because it's or equal to.
It is equal to, so that means it can equal to. Guys, should the arrow go to the right or the left?
Right.
It should go to the right because all solutions are greater than or equal to 2. Okay, so tonight's homework is 8.1. You're going to find it on Big Ideas, and there are 9 problems.